Hello, everyone. So by this time, you should be more familiarized with the software we're going to use to do this quick demonstration on the inclined plane laboratory. Um, the only thing I will say is don't use this. Part of the lab is for you guys to read this graph, analyze the friction and non-friction situations, and that's basically it. If you read the procedure, here, it says that you have to test it without friction using the formula acceleration equals to g sine alpha. So the angle should not be more than 50 degrees, between 20 and 50. So I'm going to use this. No friction starts from the rest. And the mass, they don't specify. No, yeah, they specify to be at least less than 5 kilograms or 4 kilograms. So put there. Remember to remove the bouncing and velocity versus time, okay? Also, I use the scale of 10 because when I play this, you can easily see the data points. You can probably even go higher or two. Yeah, 25 maybe a little bit too much to read it, so leave it on 10. There will be some uncertainty, some discrepancy, but that's fine. It says to compute the theoretical acceleration with the formula Ag sine alpha, and you want to compare with the one given in the simulation. And you will be doing this a few times. So let's record it to show you what you have to do. So there. Okay. Make sure the high is the maximum. It doesn't really, well, it gets to 10, but it doesn't really get to 10 here, or this will be 2 seconds here. Each division here will be 2 seconds. Each one here will be, or each one here will be 1 second. So this is 2. And here will be 1 meter per second, 1 meter per second, and here will be 10 meters per second. So 10 meters per second at about, here they show you kind of, it's, I would say 1.8. So you just divide 10 by 1.8, and that's your experimental acceleration. So 5.56. Just do it 2 or 3 times and then do the comparisons. It's pretty simple. It's not really that difficult. The same with friction. Friction, the settings are about the same. The friction cannot go beyond 1, so you can just leave it at 0.3. 2.5, no more than 2.5 or 2.5 kilograms. That's what it says in the instructions. So 2.5. Velocity versus time. You have to draw the free body diagram here. So don't forget, you have the weight, the normal force going up, the mg cosine, mg sine, as you should know from the lecture. And we use the normal equals to mg cosine to find the friction. Friction equals to mg cosine theta, where the angle theta is this one, times mu, which is this one here. So you will find, draw a free body diagram of the mass and show all, okay, and the theoretical computation of the theoretical coefficient of it. Okay, so you will find the acceleration. Okay, that's a good experiment. You will do the same, and clearly it's going slower. Yep. So it marks here 1 to 2.5 seconds. And here will be about 2, 4, 6, 8.1, 8.2. So you will estimate the theoretical acceleration, and then you will use the equations of forces. So you might need some help for that. Hopefully from the lecture you will cover this, but basically you will have mg sine theta minus mg cosine theta times mu equals to mass times acceleration. So mass doesn't matter. So g sine theta, which was the acceleration without friction, minus g cosine theta mu equals to acceleration. So acceleration, you will find it in the graph. And theta is given. G is equal to 9.8. And that's how you compute. So you will do this a few times. Well, actually, for another math, you have to repeat the experiment only twice. So once you do that, you will compare the values of mu. So you will compare the values of mu, the coefficient of kinetic friction. And that's it, pretty much. So in calculation, they also ask you to calculate acceleration using both. So yeah, so basically in that section, you can use the theoretical mu and find the acceleration, and then you can compare it with the one that you got from the graph. Use information from the graph to find the length of the incline. Okay, so if you have the acceleration and the initial speed, you can find the length of the graph, the length. I would say to find the length of the plane, you can use the equation. X equals to V initial times time, plus or minus 1/2 times gravity times square. So V initial equals to 0, so that's easy, it's just 1/2. Positive because it's accelerating, times, oh no gravity, my bad. A. Why A? Because it's not free fall. Now the time. No, you have the time. The time comes from the graph. So in this case, will be 2.5. And the acceleration will be from the graph as well. So you will find the acceleration here using rise over run, of course. The time here, and then you put in here, and you can find the length of the plane. And then there are some questions about, well, calculate the coefficient of friction. What factors affects mu? And then discuss what you demonstrated in this lab. So it's not that difficult because it's just a simulation. Just be careful with the settings. Make sure you show your free body diagram for part 2. So you know all the forces acting in the mass, the mg cosine, mg sine. Make sure you show your values. I feel like what some people miss in these simulations, in these labs, is to show more sample calculations. You know, don't just think it will just take 1 or 2 pages. If you need to do more pages in your calculations, that's fine. Okay. So that's it. So you have 2 experiments on Newton's laws. The next one that I will be doing or talking about, the next tutorial will be about circular motion. All right. So guys, see you in the next tutorial. And have a good day.